Hello there, amazing students, amazing people, and all the lovers of chemistry out there. I am super excited to be here with you on yet another practice exercise on balancing redox reactions in the basic medium. So here we have this bad boy right here, and we have been asked to balance it in the basic medium. So let's go ahead and do justice to this. So now we have this equation, and we have been asked to balance it in the basic medium. We all know our steps. I've listed them out in the previous videos on this series. So step 1, we split it into the oxidation half and the reduction half. So let's do that real quickly. So we have the first half, which is CrOH3, giving us CrO₄ minus. And then we have the other half, which is BrO₃ minus, giving us Br minus. Now, the next thing to do is to identify which half is the reduction half and which half is the oxidation half. So let's do that very quickly. For the first equation, let's find out the oxidation numbers of chromium on both sides, so we'll know whether it's the oxidation half or the reduction half. So we have CrOH3. Now, what is the oxidation number of chromium here? We do not know, so we call it X. And then we have this bracket. The oxidation number of oxygen in compounds is -2. So, and we also have the oxidation number of hydrogen in compounds, which is +1. And then this 3 here takes the entire bracket, so this becomes multiplied by 3. Everything is equal to the overall charge, which in this case is 0. So we have X plus -2 plus 1 gives us -1 multiplied by 3 equal to 0. So we have X plus -1 times 3 gives us -3. This is equal to 0. So we have X minus 3 is equal to 0. X is equal to +3. So the oxidation number of chromium here is +3. So let's find out the oxidation number of chromium on the other side, so we can decide if it is oxidation or reduction. On the other side, we have CrO₄ minus. The oxidation number of chromium here we do not know, so we name it X plus. The oxidation number of oxygen is -2 in compounds, multiplied by the number of oxygen atoms we have, which is 4, equal to the overall charge, which in this case is -2. I'm sure you're seeing how I'm taking all these steps. So now we have X plus -2 times 4 gives us -8, and everything is equal to -2. So next we have X minus 8 is equal to -2. And then we have X is equal to -2 plus 8. So X is finally equal to +6. So now the oxidation number goes from +3 all the way to +6. So we know that the oxidation number increases, and when oxidation number increases, we simply say that oxidation has occurred. So therefore this is our oxidation half. This is our oxidation half. Let's do the same thing from this other equation and see if we're going to come up with reduction. So now we have in the first compound we have BrO₃ minus. So in this case we don't know the oxidation number of bromine, so we name it X plus. The oxidation number of oxygen over here is -2 times the number of atoms of oxygen that we have, which is 3, equal to the overall charge, which is -1. So now we have X plus -2 times 3 gives us -6. This is equal to -1. So we have X minus 6 equal to -1. So we have X is equal to -1 plus 6. X is equal to +5. That is the oxidation number of bromine in this compound. On the other hand, however, we have Br minus. The oxidation number of bromine in this compound is -1. So we have the oxidation numbers moving from +5 all the way to -1. That tells us that this has been reduced. So automatically this becomes our reduction half. So we have identified the oxidation half and we have identified the reduction half. So now that we have identified our oxidation and our reduction halves, the next step or the next rule says to balance every other atom apart from oxygen and hydrogen. Now for the first equation, the only elements we have apart from oxygen and hydrogen is chromium. You can see I just identified it over here. And chromium is one atom apiece. That is, we have one atom of chromium here on the left hand side and one atom of chromium here on the right hand side. So it is balanced. And for the other equation, there is just one atom of bromine here and one atom of bromine here. So it is also balanced. So we move on to the next step, which says to balance oxygen atoms using H2O, and then balance hydrogen atoms using hydrogen ions or H+. So let's go for the first equation. We have CrOH3 giving us CrO₄². So let's balance oxygen first. On the left hand side, you can see we have 3 atoms of oxygen because these 3 over here affects everything that is in the bracket before it. So we have 3 atoms of oxygen, and on the right hand side we have 4 atoms of oxygen, which means we need to now add just 1 molecule of water to balance the oxygen atoms on both sides. So you can see we have 4 atoms of oxygen here, and then we have 4 atoms of oxygen on the left hand side. Now we need to balance hydrogen using H+ ions. So on the left hand side, how many hydrogen atoms do we have? We have 3 because this bracket also contains hydrogen, and these 3 affects everything that is in the bracket. So we have 3 atoms of hydrogen plus another 2 atoms of hydrogen here. 3 plus 2 will give us 5. So we need to add 5 hydrogen ions to the other side to balance hydrogen atoms. I'm sure you're seeing how every step is being played out. Now for the other equation, we have BrO₃- giving us Br-. Now, which side has more oxygen atoms? This side, of course, the left hand side. And we have 3 atoms of oxygen, which means we need to add 3 molecules of water to the right hand side to balance oxygen atoms. Now that we have done that, now we need to balance hydrogen atoms. How many hydrogen atoms do we have on the right hand side? We have 6. And how many hydrogen atoms do we have on the left hand side? We have none. So that means we need to now add 6 hydrogen ions to the left side to balance both hydrogen and oxygen. So now we have both equations where we have balanced hydrogen and oxygen. For the first one, we have CrOH3 plus H2O giving us CrO₄² plus 5H+. And then we have BrO₃- plus 6H+, giving us Br- plus 3H2O. So I'm sure you can see how we've gotten to this step. Now the next step says to balance the charges on both sides using electrons. So let's do that very quickly. So now, in order to balance the charges using electrons, we need to know what the charge is on both sides of each equation, so we'll know where to add electrons. Now, for the first equation, we have CrOH3 plus H2O yielding CrO₄- plus 5H+. Now, on this left-hand side, are there any charges? Do you notice any plus or any minus sign? Of course not. So the charge here basically is 0. But over here on the right hand side, you can notice some signs. Over here we have a charge of -2. And then over here we have a charge of +1 multiplied by 5 atoms of hydrogen ions, which gives us +5. So the total charge over here is 0, and the total charge over here is -2 plus 5, which gives us +3. So that means we need to balance this charge in order to make it equal to this 0. How do we do that? We simply add 3 electrons. So therefore, this equation now becomes CrOH3 plus H2O given CrO4 2 minus plus 5H plus 3 E minus, or 3 electrons, whichever one you choose to call it. I'm sure you can see how that was carried out. Now let's do for the second equation. For the second equation, we have BrO3 minus plus 6H plus giving us Br minus plus 3H2O. Now on the left hand side, how many charges do we have? We have a minus sign here, which indicates a charge of -1, plus we have a charge of plus here, which indicates a charge of +1 times the number of atoms that own that charge, which is 6. So the total charge here becomes -1 plus 6. So the total charge here is +5. On the other side, however, we have a charge of -1 on this bromine, and over here there are no charges. This hydrogen or this water molecule is basically neutral. The charge is 0, so it becomes -1 plus 0, which is -1. So on the left hand side we have a charge of +5. On the right hand side we have a charge of -1. So we need to add the number of electrons to this +5 that will make it equal to this -1. So the number of electrons we need to add now becomes 6 electrons to make it equal to this. So if we write that out in the equation, let's write out our first equation. We have CrOH3 plus H2O giving us CrO4 2 minus plus 5H plus 3E minus. And then for our other equation, we have BrO3 minus plus 6H plus 6E minus, because that's where we are adding the electrons, giving us Br minus plus 3H2O. So I'm sure you've seen how we've carried out that step. Now the next thing to do is to make sure that the electrons are equal in both equations. How do we do that? Let's move on to that step. So now we want to make sure that the electrons are equal in both reactions. On the first equation, we have 3 electrons. On the second equation, we have 6 electrons. So in order to make them equal, we'll just simply multiply this equation by 2. And then we'll leave this one just the way it is, because we want to make sure that there are an equal number of electrons in both equations. So doing that, multiplying by 2, now we have 2 CrOH3 plus 2H2O giving us 2CrO4 2 minus plus 10H plus and then plus 6E minus. And then the other equation stays basically the same. BrO3 minus plus 6H plus 6E minus, giving us Br minus plus 3H2O. So at this point now we can cancel out the electrons. 6 electrons here cancels out 6 electrons here. So what we are left with at this point now becomes 2 CrOH3 plus 2H2O, giving us 2 CrO4 2 minus plus 10H plus. And then the other equation becomes BrO3 minus plus 6H plus, giving us Br minus plus 3H2O. I'm sure you're understanding how we're getting this. Now, the next step says you have to combine both equations together. Combine both equations together. So let's combine them. Everything on the left hand side goes with everything on the left hand side, and everything on the right hand side goes with everything on the right hand side. So let's do that real quickly. Now combining both equations will now give us 2 CrOH3 plus 2H2O plus BrO3 minus plus 6H plus, then giving us 2 CrO4 2 minus plus 10H plus, giving us plus Br minus, then plus 3H2O. I'm sure you've seen how we have arrived at this. Now, let's do a bit of math before we move on to the next step, because the next step says we need to add an equal number of OH ions to both sides of the equation wherever we see H plus ions. So before we do that, let's do a bit of math. On both the left hand and on the right hand side, are there any molecules or any elements that are identical that we can cancel out? On this left hand side, you can see there are 6 hydrogen ions, and on the right hand side you can see there are 10 hydrogen ions. So therefore that means we can eliminate 6 from 10. That will leave the left hand side with no hydrogen ions, and then the right hand side with 4 hydrogen ions. Basically it's just like saying 10 minus 6, which gives us 4. So on the left hand side you can see we have 2 water molecules, and on the right hand side we have 3 water molecules. So having 2 water molecules on the left hand side and having 3 water molecules on the right hand side means we can eliminate this. That leaves us with 0, and then this place now leaves us with just 1 water molecule. If we do that math, what we're going to be left with now will now become 2 CrOH3. Since we've eliminated this water molecule, no more water molecules there, so we have BrO3 minus, then we have 2 CrO4 2 minus, then plus. Now we eliminated 6 from these 10 hydrogen ions, so what we have is 4H plus, and then plus Br minus plus H2O. I'm sure you saw how we did all of that. Now the next step says for every H plus ion that you see in the equation, add an equal number of OH minus to both sides to balance it. So let's do that real quickly. Now in order to add an equal number of OH minus ions to both sides, we need to find out how many H plus ions we have. So we have 4 atoms of 4 H plus ions over here. So that means we need to add 4 OH minus to this side and then add 4 OH minus ions to the right hand side. So if we do that, what we're going to end up having is 2CrOH3 plus BrO3 minus plus 4OH minus, giving us 2CrO4 2 minus plus 4H plus Br minus plus H2O plus 4OH minus. We've done that excellently well. Now, the next step, which is I think the second to the last one, says anywhere you see H plus ions and OH minus ions, add them together to form H2O. So now we have H plus ions here and we have OH minus ions here, and we both have 4 H plus ions here, and also we have 4 OH minus ions here. So that tells us that we'll get 4 water molecules when we add the two of them. So doing that now, we are going to end up having 2CrOH3 plus BrO3 minus plus 4OH minus, giving us 2CrO4 2 minus plus 4H2O plus Br minus, and then plus H2O. Now, before we get to our final equation, you can see we have H2O here and another H2O. 4H2O plus 1 molecule of H2O. So that tells us that 4 plus 1 gives us 5 molecules of water. So for our final equation, what we're going to end up having is 2CrOH3 plus BrO3 minus plus 4OH minus, giving us 2CrO4 2 minus plus 5H2O plus Br minus. So this is our final equation. So now this is our final equation, but just to be on the safe side, we want to check to see if the atoms are balanced on both sides and if the charges are balanced on both sides. So let's start with the first atom, which is chromium. On the left hand side, we have 2 atoms of chromium because of this coefficient of 2. On the right hand side, we also have 2 atoms of chromium. So we have 2, 2. Chromium is balanced. For oxygen, we have, let's start with this bracket over here. This bracket means that everything in this bracket is affected by this number 3. So we have 3 atoms of oxygen first, and then remember we also have this 2, which is the coefficient that affects the entire compound. So that becomes 3 times 2, which is 6 atoms of oxygen, plus over here we have 3 atoms of oxygen. So that becomes 6 plus 3 plus, and then over here we have 4 atoms of oxygen, which becomes plus 4. 6 plus 3 plus 4 gives us 13. On the right hand side, how many atoms of oxygen do we have? We have 4 atoms of oxygen over here, multiplied by these 2, which is 8, plus over here we have 5 atoms of oxygen because of this coefficient of 5. 8 plus 5 is also 13. So oxygen is 13 on the left hand side and 13 on the right hand side. It is balanced as well. Now let's check for hydrogen. How many atoms of hydrogen do we have? This coefficient of 2 affects everything that is in this compound. So these 3 atoms of hydrogen is multiplied by these 2, which gives us 6, plus we have 4 atoms of hydrogen over here, because these 4 affects everything in this compound. So we have 6 plus 4, which gives us 10. So on the left hand side, we have 10 atoms of hydrogen. On the right hand side, however, we have 5 here, which multiplies these 2. 5 times 2, that gives us 10 as well. So hydrogen is also balanced. And now we're talking about the final atom, which is bromine. So on the left hand side, we have 1 atom of bromine. Right hand side, we have 1 atom of bromine. So bromine is also balanced. If you want to check the charges as well, you would find out that they are also balanced. So our final balanced equation is 2CrOH3 plus BrO3 minus plus 4OH minus, giving us 2CrO42 minus plus 5H2O plus Br minus. I'm sure you see how we did this from A to Z. So I took all these steps basically so you could follow each step of the way. If this channel educated you in any profitable way, I'd like you to smash that subscribe button, like this video, and turn on the notification bell icon. So when more educational stuff like this comes out, you'd be the first to be notified. I'll see you in the next practice exercise. Until then, my name is David, and what I do here is to take the mystery out of chemistry so Chemi can make history. See you in the next one.